This video is about conic section ellipse. It is a grade 11 pre-calculus lesson. Ellipse is a two-dimensional closed curve where the sum of the distances between any point on it and two fixed points, called the focus points, is the same. It is formed when a plane intersects a cone at an angle to the cone's axis. So this is our illustration. This is our plane and this is our cone. And an ellipse here is formed. Ellipse can be elongated horizontally, like this one. So the parts of the ellipse, we have the center. This is called the major axis. This is called the minor axis. And let's take note that the length of major axis is 2 times A, while the length of minor axis is 2 times B. The endpoints of the major axis are called the vertices. So we have here vertex 1 and vertex 2, while the endpoints of the minor axis are called co-vertices. So we have here vertex 1 and vertex 2. The foci are somewhere here. So we have here focus 1 and focus 2. To illustrate the definition of ellipse, we are going to pick any 2 points that are on the ellipse. For example, we have point A here, and then we'll pick another point, point B here. The distance from A to F1 plus the distance from A to F2 equals the distance from B to F1 plus the distance from B to F2. So we can write A F sub 1 plus A F sub 2 equals B F sub 1 plus B F sub 2. Ellipse can also be elongated vertically like this. The parts of the ellipse, we have here the center, and this is called the major axis. This is called the minor axis, and the length of major axis is always 2 times A, while the length of minor axis is always 2 times B. The endpoints of the major axis are called the vertices. So we have here vertex 1 and vertex 2, while the endpoints of the minor axis are the co-vertices. So we have here co-vertex 1 and co-vertex 2. The foci are somewhere here. So we have focus 1 and focus 2. Again, to illustrate the definition of ellipse, we are going to pick any 2 points that are on the ellipse. For example, point A here, and then we have point B here. The distance from A to F1 plus the distance from A to F2 equals the distance from B to F1 plus the distance from B to F2. So we can write A F sub 1 plus A F sub 2 equals B F sub 1 plus B F sub 2. So this table shows the 4 forms of our ellipse: the center, the foci, the vertices, and the co-vertices. So if our equation starts with x squared, like the first and the second, our ellipse is elongated horizontally. While if our equation starts with y squared, like the third equation and the fourth equation, our ellipse is elongated vertically like this. So let's take note that A is always greater than B. Now we are going to use this table in finding the center, the foci, the vertices, and co-vertices of ellipse. Example number 1. Write 4x squared plus 25y squared minus 100 equals 0 in standard form. Find center, foci, vertices, and co-vertices, and graph. So our equation is in general form, and we are going to write down our equation. So we have 4x squared plus 25y squared minus 100 equals 0. The first thing that we are going to do here is to transfer this negative 100 to the other side. So we have 4x squared plus 25y squared equals 100. These are our standard forms, and the right side is 1. So that means our right side here must also be 1. So to do that, we are going to divide our equation by 100. So 4 divided by 100 is 1 over 25, while 25 over 100 equals 1 over 4, and 100 divided by 100 equals 1. So this is our equation. We have x squared over 25 plus y squared over 4 equals 1. Since our equation is already written in standard form, we are going to complete the information below. Let's take note that our a here is 5, that's the square root of 25. Our b is 2, that's the square root of 4. Now the center has coordinates 0, 0. It's here. For our foci, we are going to solve for c first. Our formula is c equals square root of a squared minus b squared. Our a is 5, our b is 2, so that means c equals the square root of 5 squared minus 2 squared. 5 squared is 25, and 2 squared is 4. 25 minus 4 is 21, so our c is square root of 21. Now, since the coordinates of our foci are negative c and 0, and c 0, so that means the coordinates are negative square root of 21, 0, and square root of 21, 0, and they are somewhere here. Now for our vertices, the coordinates are negative a 0 and a 0. Our a is 5, so that means the coordinates are negative 5, 0, and 5, 0, and they are here. For our co-vertices, the coordinates are 0b and 0, negative b. Our b is 2, so that means the coordinates are 0, 2, and 0, negative 2, and they are here. Now we can draw our graph. So this is our graph. Example number 2. Write 36x squared plus 9y squared minus 324 equals 0 in standard form. Find the center, the foci, vertices, and co-vertices, and graph. So this is our equation. The first thing that we are going to do here is to move negative 324 to the other side. So it becomes 36x squared plus 9y squared equals 324. So the right side of our standard form should be equal to 1. So that means we are going to divide our equation by 324 so that the right side will be equal to 1. 36 divided by 324, that's 1 over 9. While 9 divided by 324, that's 1 over 36. And of course, 324 divided by 324 equals 1. Now notice here that we switch y squared and x squared. Why? Because the denominator of y squared is 36. It's greater than 9. So remember that our a should always be greater than b. We are going to complete the information. Now again, let's take note that our a here is 6, which is the square root of 36. Our b is 3, which is the square root of 9. Our center here has coordinates 0, 0. So it's here. Now for our foci, let's solve for c first. And our formula is c equals square root of a squared minus b squared. Our a is 6, our b is 3. So that means c equals square root of 6 squared minus 3 squared equals square root of 27, which is equal to 3 square root of 3. So the coordinates of our foci are 0, c, and 0, negative c. So that means 0 and 3 square root of 3 and 0, negative 3 square root of 3. And they are somewhere here. Now for our vertices, the coordinates are 0a and 0, negative a. Our a is 6, so that means the coordinates are 0, 6, and 0, negative 6. They are here. For our co-vertices, the coordinates are negative b and 0, and b and 0. Our b is 3, so that means the coordinates are negative 3, 0, and 3, 0. They are here. Now we are going to draw our ellipse. This is our graph. Example number 3. Write 9x squared plus 4y squared plus 54x minus 8y plus 49 equals 0 in standard form. Find center, foci, vertices, co-vertices, and graph. So our equation is in general form. So we are going to copy down our equation. The first thing we are going to do is to move this plus 49 to the other side, and then group together all terms with same letters. So we have here 9x squared and 54x, and then we have 4y squared and negative 8y, and then 49 becomes negative 49 on the other side. Now from here, we are going to factor out the coefficient of x squared here, and also factor out the coefficient of y squared here, which is 4. So that means we have 9 times the quantity x squared plus 6x. Then we have 4 times the quantity y squared minus 2y. So if we are going to check, we are going to multiply back. 9 times x squared is 9x squared. 9 times 6x, that's 54x. And also 4 times y squared is 4y squared. 4 times negative 2y equals negative 8y. Now we are going to complete the square. So to complete the square for x squared plus 6x, we are going to find half of 6, which is 3, then square it, and that's 9. So that means we are going to add 9 here. Then for y squared minus 2y, 1/2 of negative 2 is negative 1. Negative 1 squared is 1, so that's why we added 1 here. Now 9 times 9 is 81, so we add 81 to the other side. And also 4 times 1 is 4, so we are also going to add 4 on the other side. Now since x squared plus 6x plus 9 is a perfect square trinomial, it can be written as the quantity x plus 3 squared, and our 9 is still here. And also y squared minus 2y plus 1 is a perfect square trinomial. It can be written as the quantity y minus 1 squared, and then our 4 is still here. Then negative 49 plus 81 plus 4 equals 36. The right side should always be equal to 1. So to make this right side become 1, we are going to divide our equation by 36. So 9 divided by 36 is 1 over 4, while 4 divided by 36 is 1 over 9, and of course 36 divided by 36 equals 1. So this is our equation. And the quantity y minus 1 squared over 9 plus the quantity x plus 3 squared over 4 equals 1. Now, since we already know our standard form, we are going to complete the information. So let's take note that our a here is 3. That's the square root of 9. and our b here is 2. That's the square root of 4. Our center here has coordinates hk, that's -3, +1. Take note that this is x plus 3, our h is -3. This is y minus 1, our k is +1. And it's here. For our foci, we need to solve for c. And our formula is c equals square root of a squared minus b squared. And a is 3, b is 2, so that means c equals square root of 3 squared minus 2 squared, which is equal to square root of 5. Now, our h is -3, our k is 1, and our c is square root of 5. Substituting these numbers into our formula here, the coordinates of the foci are -3 and 1 plus square root of 5, and -3, 1 minus square root of 5. And they are somewhere here. And for our vertices, the coordinates are h and k plus a, and h and k minus a. Our h again is -3, our k is 1, and our a is 3. So substituting these numbers into our formula, so the coordinates of our vertices are -3 and 4, and -3 and -2, and they are here. Then for our co-vertices, the coordinates from the table are h minus b and k, and h plus b and k. So again, h is -3, k is 1, and p is 2. Substituting these numbers into our formula, the coordinates of the co-vertices are -5 and 1, and -1, 1. So they are here. Now, we can draw our ellipse. So this is our graph. Example number 4. Given the equation, the quantity x minus 2 squared over 25 plus the quantity y minus 3 squared over 16 equals 1, complete the information below, graph, and then write in general form. Now let's take note again that our a here is 5. That's the square root of 25. Our b is 4. That's the square root of 16. And our center has coordinates hk. So that's 2, 3. So again, let's take note. We have here x minus 2. H is 2. We have here y minus 3. Our k is 3. So our center is here. For our foci, we need to find c. So our formula is c equals square root of a squared minus b squared. Our a is 5, our b is 4, so that means c equals square root of 5 squared minus 4 squared, and that gives us 3. That's because 5 squared is 25, and then 4 squared is 16. 25 minus 16 is 9. Square root of 9 is 3. So our h is 2, our k is 3, our c is also 3. So substituting these numbers into our formula here, the coordinates of our foci are -1 and 3 and 5 and 3. So they are here. So for our vertices, our coordinates are h minus a and k, and h plus a and k. So again, our h is 2, our k is 3, and our a is 5. So substituting these numbers into our formula, the coordinates are -3 and 3 and 7 and 3, which are here. Now for our co-vertices, the coordinates are h and k plus b, and h and k minus b. Our h again is 2, our k is 3, and our b is 4. Substituting these numbers into our formula, the coordinates of our co-vertices are 2 and 7 and 2 and -1. They are here. Now we can draw our ellipse. This is our graph. Now we are going to write our equation in general form. So this is the general form. So the right side will be equal to 0. So this is our equation. The first thing we are going to do is multiply our equation by the least common denominator. So between 25 and 16, the least common denominator is 400. So we are going to multiply our equation by 400. So 400 times the quantity x minus 2 squared over 25 is 16 times the quantity x minus 2 squared. Plus, when you multiply 400 times the quantity y minus 3 squared over 16, we have 25 times the quantity y minus 3 squared. And then 400 times 1 is 400. Now the next thing we are going to do is to expand the binomials x minus 2 and y minus 3. So x minus 2 squared is x squared minus 4x plus 4, while y minus 3 squared is y squared minus 6y plus 9. Now we are going to apply distributive property of multiplication, that 16 times x squared is 16x squared. 16 times -4x, that's -64x. 16 times 4, that's 64. Then 25 times y squared equals 25y squared. 25 times -6y equals -150y. Then 25 times 9, that's 225. Now we are going to arrange. It starts with the term with x squared, then the term with y squared, then the linear term that has x, the linear term that has y, and then the constant. So we have 16x squared, then 25y squared, then minus 64x, then minus 150y. Then for our constant, we have 64 plus 225 minus 400, it's -111, and the right side is equal to 0. So this is our answer. Thanks for watching, guys. This is Teacher Regil. Keep safe.